Differentiation from first principles and the power rule. Let's go. What is differentiation? It lets us find the instantaneous rate of change, or basically the gradient of a function, at any point. We know that gradient's the change in y over the change in x, so for a straight line you can calculate it using this formula here. This should be quite familiar to you. But what if the gradient varies across the domain of a function? That's when we need to add in limits. So from first principles, the definition of a derivative is equal to this expression here. As you can see, it's just the formula of the gradient, but with a limit as the difference becomes infinitely small. And as this difference becomes infinitely small, then the gradient at any given point becomes more and more accurate to the true value. So as you know, differentiation occurs when we use the power rule, so multiply by the power, subtract 1 from the power, that's how you differentiate. We're going to prove that using the limit definition of the derivative. So first, let's use binomial expansion to expand out the top. We can see that x to the power of n cancels here, so we can rewrite that, and also rewrite the choose function in terms of n's and factorials. Divide the numerator by h to simplify everything, and then apply the limit here. Now anything that contains a h term in it will basically go to 0, because that's the difference h becoming infinitely small. And then we end up with our final answer, so we just prove the power rule. So for all natural numbers, the power rule works here. It only holds for integer exponents though, but we can actually extend this proof to include all real numbers by using the chain rule. So how does that work? So first we need to rewrite x to the power of n in terms of exponentials. We know that n ln of x differentiates to n over x, so we can multiply the derivative of e to the u by n over x, simplify everything down and use our indices rules, and then we're left with another proof of the chain rule here. Try it yourself then. Can you differentiate f of x equals x cubed plus 4x from first principles?